Welcome to two projects. In this video, we are going to explain the project ACGAN Unbalanced Data Processing Decision Making in Network Attacks based on ACGAN and Machine Learning. Introduction. This project aims to revolutionize network intrusion detection by introducing a novel strategy known as ACGAN, that is, Auxiliary Classifier Generative Adversarial Network. Through the integration of ACGAN and machine learning techniques, the project seeks to address the challenges posed by unbalanced data in network attacks, enhancing the accuracy and efficiency of intrusion detection systems. With the ever-evolving landscape of cyber threats, the project responds to the pressing need for an advanced defense mechanism. Unbalanced data characteristic of network intrusion scenarios often leads to insufficient classification and detection omission. ACGAN is designed to mitigate these challenges and significantly improve the overall defense capability of network security systems. And ACGAN leverages the approximate consistency of generated samples with input data distribution while introducing a random distribution within a bounded interval. This innovative approach aims to overcome the limitations of existing classification algorithms, particularly in handling unbalanced network traffic data. And the primary beneficiaries of this project are organizations and individuals relying on robust network security measures. Improved intrusion detection capabilities translate to enhanced protection against cyber threats, safeguarding sensitive data and ensuring the uninterrupted operation of critical systems. Additionally, the broader cybersecurity community stands to benefit from the advancements made in addressing the challenges posed by unbalanced data in network attacks. And the ACGAN strategy as proposed in this project holds the potential to empower defense systems with superior accuracy, precision, recall, and overall performance. By addressing issues such as data imbalance and detection omission, the project contributes to the development of network security models with heightened generalization ability, equipping them to effectively handle diverse and evolving forms of cyber threats. Objective of the project. So we aim to employ AEC-GAN. AEC-GAN uses auxiliary classifiers and GANs to improve intrusion detection by addressing data imbalance. In intrusion detection, the presence of imbalanced datasets can lead to insufficient classification and detection omission, especially for minority classes representing rare intrusion patterns. The AEC-GAN strategy employs generative adversarial networks to generate synthetic samples for underrepresented classes. This counteracts the imbalance, providing the model with more examples of minority class instances. Additionally, the use of auxiliary classifiers helps the model focus on specific classes, improving its ability to correctly classify and detect intrusions that may have been overlooked due to data imbalance. And we aim to expand generated samples to enhance recognition of unbalanced network traffic for improved intrusion detection. Unbalanced network traffic data poses challenges in recognizing different degrees of intrusion patterns, and AEC-GAN tackles this issue by expanding the dataset through GAN-generated samples. By introducing synthetic instances that capture a wider range of intrusion scenarios, the model becomes more adept at recognizing the diverse nature of network traffic data. This expanded dataset helps the model generalize better, ensuring improved recognition accuracy across various degrees of data categories and quantities, therefore enhancing the overall efficacy of intrusion detection. And we aim to develop AEC-GAN, a defense model combining GAN and machine learning to optimize intrusion detection metrics. The AEC-GAN defense model is a holistic approach that combines the strengths of GANs and traditional machine learning to address data imbalance in intrusion detection. By integrating GANs from data augmentation and machine learning for classification, the model seeks to balance the dataset, ensuring equal representation of different intrusion classes. This equilibrium contributes to improved accuracy, precision, recall, and F-value indexes. And the defense model aims to enhance overall intrusion detection performance by leveraging the capabilities of both GANs and machine learning algorithms, providing a robust and adaptive solution to the challenges posed by imbalanced network traffic data. Requirements needed to execute this project are: software requirements. Software used is Anaconda, primary language used is Python, front-end framework used is Flask, Backend framework used is Jupyter Notebook. Database used is SQLite 3. And front-end technologies used are HTML, CSS, JavaScript and Bootstrap 4. Hardware requirements needed are operating system of Windows, processor of i5 and above, RAM of 8GB and above, hard disk of 25GB and above. Now we'll discuss the working modules of Law of Work. The first step is importing required packages. In this step, we will import essential libraries such as NumPy and Pandas for data manipulation and analysis, sklearn for machine learning and data pre-processing, Matplotlib and Seaborn for data visualization. The second step is exploring the dataset. So the project involves the exploration of NSL-KDD dataset. So this exploration phase includes tasks like loading the data, understanding its structure and conducting initial data analysis to gain insights into the dataset characteristics. The third step is data processing. So in this step we utilize Pandas for creating a data frame, drop unnecessary columns, scale the data and convert it into tensors using the Torch library. Preparing the dataset for model training with generative adversarial networks. The fourth step is visualization using Seaborn and Matplotlib. In this step, we employ Seaborn and Matplotlib to create visual charts and graphs, facilitating a better understanding of dataset characteristics. The next step is label encoding using label encoder. So here we apply label encoding to convert categorical labels into numerical format, facilitating the training of machine learning models that require numerical input. The next step is feature selection. So in this step we choose relevant features for model training, enhancing model performance and reducing dimensionality if necessary. The next step is train and test split. In this step we segregate the dataset into training and testing subsets. The training subset is used for training the models, while the testing subset evaluates the model's performance on new data. The next step is training and building the model. So in this step, multiple machine learning models are trained using the prepared dataset. These models are evaluated using various performance metrics, accuracy, precision, recall and F-score to determine their accuracy and suitability for arrival delay prediction. And in the next step, that is extension phase, a hybrid model was created by combining predictions from multiple models for improved accuracy. Additionally, a user-friendly Flask-based frontend with authentication was also developed. And the next step is Flask framework with SQLite for sign-up and sign-in. So in this step, we integrate user registration and login functionalities into the Flask framework. Users can sign up by providing their information and subsequently they can securely log in using their credentials. This enhances system security and allows for personalized user experiences. So after signing in, users provide input through the front-end interface. The input data is pre-processed to prepare them for prediction by the trained models. So this pre-processing step ensures that user-provided data are in a suitable format for the model. And the pre-processed user input is fed into the trained models for prediction. The best performing model is selected to make predictions based on the input data. And the predicted outcome is displayed through the front-end interface, allowing the user to view the results of the model's predictions or analysis. Now we'll understand about the algorithms used. The first algorithm built is GBDT-KNN, that is gradient boosting decision trees with k nearest neighbors. So it is ensemble learning with GBDT which boosts decision trees followed by KNN for classification. It combines strengths of both algorithms for improved accuracy in identifying intrusion patterns. The second algorithm built is k nearest neighbors, that is KNN. So it classifies data points based on the majority class of their k nearest neighbors. It is robust and simple and is effective in identifying similar patterns in network traffic data. The next algorithm used is backpropagation neural network, that is BP. It utilizes a multi-layered neural network trained through backpropagation to learn intricate patterns in network data, enhancing the model's ability to classify different types of intrusions. The fourth algorithm built is logistic regression. So it is a linear model for binary classification. It estimates the probability of an event occurring, suitable for intrusion detection with a straightforward interpretation of coefficients. The next algorithm used is radial basis function network, that is RBF. It is a neural network with radial basis functions as activation functions. It is effective in capturing non-linear relationships in data, contributing to accurate intrusion detection. The next one is ADA Boost. So it is a boosting algorithm that combines weak classifiers to create a strong one. It is adaptable to diverse intrusion patterns, enhancing overall classification accuracy. The next one is support vector machine, that is SVM. It separates data into classes using hyperplanes, maximizing the margin between them. SVM is effective in intrusion detection due to its ability to handle complex data distributions. The next algorithm used is extreme learning machine, that is ELM. It is a single layer feed-forward neural network with randomly assigned hidden layer weights. It is efficient in learning complex relationships in data, contributing to accurate intrusion detection with reduced training time. And the last algorithm used is AEC GAN, that is auxiliary classifier GAN. It is GAN augmented with auxiliary classifiers to generate synthetic samples for underrepresented intrusion patterns. It enhances the model's ability to detect rare network threats by addressing data imbalance. Comparison graphs. So this is the horizontal bar graph comparing accuracies of different algorithms. In this graph on x-axis I have accuracy scores and on y-axis I have algorithm names. So accuracy measures the overall correctness of predictions, showing the percentage of correctly classified instances. This is precision comparison graph. In this graph on x-axis I have precision scores and on y-axis I have algorithm names. So precision measures the accuracy of positive predictions, indicating how many predicted positives were actually correct. This is recall scores comparison graph. In this graph on x-axis I have recall scores and on y-axis I have algorithm names. Recall measures the ability to identify all relevant instances, showing how many actual positives were correctly predicted. And this is F-score comparison graph. In this graph on x-axis I have F-scores and on y-axis I have algorithm names. So F-score combines precision and recall into a single metric, balancing accuracy and completeness in predictions. So the algorithm which is best performing in all the performance metrics will be used for predictions. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is NSL-KDD folder in which I have NSL-KDD intrusion dataset on which we will train the models. So this dataset contains 5 class labels 0, 1, 2, 3 and 4. So 0 is DDoS, 1 is probe, 2 is R2L, 3 indicates U2R and 4 indicates normal, that is not an intrusion. And this is static folder. This folder consists of files related to CSS, JavaScript and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML pages. And these are model files which contains algorithm information. These files will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. And this is signup.db file. This file is the database file used to store user information. So now copy the path of the code folder from the address bar of the file explorer. I am copying it. Open Anaconda prompt. Use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. So now compile the app.py file using the command python space app.py. I am typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, local host and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see a sign up link, click on it. So if we are new users, we have to register first. Fill in all these details and click on sign up button to register. And if we already have an account, we can directly log in by clicking on the sign in link. So as I already have an account, I'm clicking on this link. So here we have to provide our credentials, username and password. And click on sign in button. So it has redirected us to the intrusion detection page, and here we have to fill in these parameters. First we'll understand these parameters. The first one is service. So service indicates the type of network service, example HTTP, FTP associated with the connection. The next one is flag. So flag describes the status of a network connection, providing information on initiation, termination or errors. The third one is SRC bytes. So it represents the bytes transmitted from the source in a network connection. The next one is DST bytes. So it indicates the bytes received by the destination in a network connection. This is count. So count represents the number of occurrences of a specific event in the network. The next one is error rate. So error rate represents percentage of connections with source specific errors. The next one is same SRV rate. So it is the proportion of connections with the same network service type. The next one is different SRV rate. So it represents the rate of connections with different network service types. The next one is DST host SRV count. So it is the number of connections initiated to a specific destination host. And the next one is DST host same SRV rate. So it is the proportion of connections to a destination host with the same service type. The next one is DST host different SRV rate. So it is the rate of connections to a destination host with different service types. And the last one is DST host error rate. So it is the percentage of connections to a destination host with destination specific errors. Now we'll fill in these parameters. So service would be 20, flag is 9, SRC bytes would be 491, DST bytes would be 0, count would be 2, error rate would be 0, same SRV rate would be 1, different SRV rate would be 0, DST host SRV count is 25, DST host same SRV rate is 0.17, DST host different SRV rate is 0.03 and DST host error rate would be 0. Now click on predict button. So here we can see the predictions. So in the red color text we can see the result. There is no attack detected, it is normal. That is, there is no intrusion detected. Click on home link. We will try giving another set of parameters now. This time service would be 49, flag is 5, SRC bytes is 0, DST bytes is 0, count would be 123, error rate would be 1, same SRV rate would be 0.05, different SRV rate would be 0.07, DST host SRV count would be 26, DST host same SRV rate would be 0.1, DST host different SRV rate would be 0.05 and DST host error rate would be 1. Now click on predict button. So we can see there is an attack detected and the type is DDoS. Now click on home link. We will try giving another set of parameters again. So service would be 20 this time, flag is 9, SRC bytes would be 334, DST bytes is 0, count would be 2, error rate is 0, same SRV rate is 1, different SRV rate is 0, DST host SRV count would be 20, DST host same SRV rate would be 1, DST host different SRV rate would be 0 and DST host error rate would be 0 again. Now click on predict button. So this time there is an attack detected and the attack type is R2L. Click on home link. We we will give another set of parameters now. So I have entered the parameter values. Now click on predict button. So there is an attack detected and the attack type is probe this time. We will give another set of parameters. Click on home link. I have entered the values. Now click on predict button. So we can see the output here. There is an attack detected and attack type is U2R. Similarly, we can give any set of parameters and get the detections. Click on sign out button. So the conclusion here is the project harnessed a variety of algorithms such as GBDT, KNN, AEC, GAN and traditional models, enhancing the accuracy of intrusion detection by capitalizing on the strengths of each algorithm in identifying and categorizing network intrusions. AEC GAN was seamlessly integrated to tackle imbalanced datasets, strategically generating synthetic samples. This fortified the model's capacity to discern and categorize rare intrusion patterns, effectively mitigating the challenges posed by skewed data distributions. The incorporation of a hybrid model aggregating predictions from diverse algorithms showcased synergies that collectively strengthened the intrusion detection system. This collaborative approach contributed to heightened robustness and accuracy in identifying security threats. And the project's integration of Flask and SQLite streamlined the development of a user-friendly front-end, offering an intuitive interface for user input, interaction, and visualization of intrusion detection results. This seamless integration enhances the overall usability and accessibility of the system.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.